This is the first video covering content for Algebra 1. So you can see that by the title here, Unit 1, Lesson 1, Order of Operations. For a lot of you, this is going to be review. Okay? I can use the order of operations to simplify expressions. And I can evaluate expressions using the order of operations. These are the two things that I want you to be able to do by the end. Okay? The mathematical order of operations is used to simplify expressions correctly. All right? An expression, then, is a mathematical phrase, which means that it does not have an equal sign. Okay? An acronym often used to help us remember the order of operations is PEMDAS. Probably heard it before. If you haven't, it's right there. And what does each one stand for? P is parentheses, which when it has parentheses, you basically just simplify as much as possible within those parentheses first. E stands for exponents. M stands for multiplication or multiply. D stands for division. A stands for addition. You'll probably guess what S stands for. It would be subtraction. The reason I put boxes around a couple of the operations, the multiplication, division, and the addition and subtraction, is because those two operations are done as they appear from left to right. So what do I mean by that? Well, the first example here is what I mean by that. So 8 divided by 2 times 4. If I follow this as I say it, it would say do multiplication first and say 2 times 2 and get 8. So if I'm doing this the wrong way, it would say 8 divided by, and I would do 2 times 4 first and say 8. And then 8 divided by 8 would be 1. Okay? But if I do it the correct way, I would do whichever one of these comes first, going left to right. So I would do 8 divided by 2 first, which is 4 times 4. So if you do the multiplication first, the wrong way, you get 1. However, if you do the division first, the right way, you get 16. And therefore, the order matters. The correct answer here is 16. Okay. So, practice. So we're going to use the order of operations to simplify each expression, okay, which is learning target number 1. So, I see parentheses here. Can I simplify anything in there? I can. 14 plus 3. Notice what I'm doing here. I'm just rewriting that because I'm not doing anything with that. Minus 14 plus 3 is 17. Now it says exponents. So that's next. I'm not doing anything with 32 plus 36. 6 squared means 6 times 6 minus 17. Now addition. 32 plus 36 would be 68 minus 17. 68 minus 17 is 51. Okay? Next one is with fractions. We've done work with fractions already, and I told you it's not going away. So you're going to see it a lot here at the beginning for sure. So 1/4 plus 3/5 divided by 2. I would do division first. So 3/5 divided by 2. Remember, when you do division, you change the division to a multiplication and flip to the reciprocal. So 3/5 times 1/2. And I'm just going to, so I don't lose it. I don't want to forget about that 1/4. I'm just writing it 1/4 plus whatever that is. So now I'm going to do that. So that's 3/10. Right? 5 times 2 is 10. Now I got to do 1/4 plus 3/10. I got to get a common denominator. 4 and 10 both go into 20. 4 times 5, so 1 times 5. 10 times 2, so 3 times 2. So that would be 11/20. Okay, number 3. Now this is something I'm going to do, not every notes, but a lot of the notes I'm going to do this. I'm going to circle a problem, and I want you to try that problem on your own. So you can pause it right now, try that problem. I'm not going to give you the answer until I'm going to check it tomorrow in class, and I will look at that problem to see if you got the right answer. Okay? Moving on to number 4. So, parentheses first. Now there's also these brackets here, which is basically parentheses. So what that's saying is, with these brackets, I need to do everything in here before I multiply by 5/3. So within this bracket, though, there's parentheses. So I'm going to do both of those at the same time. 2 times 9 is 18. 15 divided by 3 is 5. Notice I'm keeping it in parentheses because there's a squared on the outside. You wouldn't have to if you just do 18 minus 5 squared. But that reminds me that I have to do the 5 squared first. Don't want to lose the 5/3, so I'm going to keep it there. That's the next one. I need to do that next. So 5/3 times 18 minus 5 squared is 25. Now I got to do 18 minus 25, so 5/3 times -7. 18 minus 25 is -7. And now I need to multiply. Final step, 5/3 times -7. I'll make that into a fraction to help. You don't have to, but it might help some people. 5 times -7 is -35. 3 times 1 is 3. -35 over 3 is my final answer. I do want to make sure, can I reduce? I cannot. That is my final answer. Okay. Backside, evaluating expressions. When we evaluate an expression, we are replacing a variable or letter with a number. It is a good habit to use parentheses when you do this. I can't stress that enough. Okay? Here's why. If I don't, like, look at this first one. 3x plus 2y. So I'm going to do 3. I'm putting 5 in for x, right? So if I just put 5 in for x, it looks like 35. Keep them separate. I'm going to do 3 times 5 plus 2 times -2. So 3 times 5. Now it's just an order of operations problem. So the only new step is we're putting numbers in place of letters. So 3 times 5 is 15 plus 2 times -2 is -4. 15 plus -4 is 11. Okay. Number 2, 2/3 x. There's those fractions again. Okay. So 2/3 times x, which is 5, minus 2 times -2. A little bit harder. So 2/5 or 2/3, not 2/5, 2/3 times 5, or 5 over 1, is 10 over 3. Now that's a minus 2 times -2 is -4. Minus -4 is actually like adding 4, so 10 over 3 plus 4, right? Minus a negative is like adding it. So that would be 10 over 3 plus, we need to make this denominator 3. 1 times 3 is 3, 4 times 3 is 12. 10 plus 12 is 22 over 3. Done. Okay, next one. A lot of parentheses here. Might get a little confusing. But when you have multiple parentheses, I would use, in the first one, I'd make it bigger and the second one smaller. So 2 times 5 minus 7 times 1/2 of y, which is -2, plus 3. So now I got basically 2 problems, and then I'm going to get my answer, and multiply them. So 2 times 5 is 10, minus 7 is 3. So that one became 3. And then this one, 1/2 of -2 is -1. Plus 3. -1 plus 3 is 2. So 3 times 2, 6. And last one here, y squared, that's -2 squared, oops, divided by, sorry, that's my mistake, 13 minus x, but x is 5. So I'm going to do my parentheses first. Now, you'd think, well, there's parentheses right there, but I can't simplify what's in the parentheses right there. It's just a number. So, but this one I can. So I'm just going to leave that -2 squared divided by 13 minus 5 would be 8. Now, -2 squared. If you use your calculator, if you rely on your calculator, you are going to run into issues in this class sometimes. And I'm going to show you what I mean. And this is also why I said parentheses was important. If I type in -2 squared without the parentheses, it gives me -4. Sorry, there's a glare. It gives me -4. It is not -4. If I put -2 in parentheses and then say square it, I get +4. So which one is it? Well, think about what squared means. It means multiply -2 times -2. What's -2 times -2? It is 4. And then 4 divided by 8, well, 4 doesn't get divided by 8. Another way of writing that is 4 divided by 8, which reduces to 1/2. Okay? Next problem. John claims that x plus y squared equals x squared plus y squared. Is John correct? Show work to provide evidence. Well, what do you think? Pause it and see what you think. Do you think those are equal or not? Okay. Hopefully you paused it and gave that a shot. Here's what we can do. We can use this idea of evaluating expressions to answer this question. I'm going to take 5 and -2 and plug them in and see if I get the same answer. So I'm going to do 5 plus -2 squared. And I'm going to see if it's equal to 5 squared plus -2 squared. And this is where order of operations comes in. What I do first here is 5 plus -2 because it's in parentheses. 5 plus -2 is 3 squared, which is 9. But this one, I can't simplify the parentheses, so I square first. So I'm going to do this first and that. 5 squared is 25. -2 squared, which we just did, is 4. 25 plus 4 is 29. Those are not equal. Okay? So, is John correct? No, he is not correct. Okay? So the example above, again, shows how evaluating expressions can be used to check your work. Now, this last little bit here is going to be used in this Canvas quiz, but it's also going to be used later in Unit 1 and in other units, so we want to get this out of the way right now. A symbol you should know. That's just a little squiggle there. Doesn't really mean, I just want to show you the 2 bars. Those are absolute value bars. They're just vertical bars. They're not parentheses. They're not brackets. Okay, a lot of people look at those and they think brackets. They are not brackets. They represent a certain number's distance from 0. So, on this number line up here, I've labeled that point -4. How far is -4 from 0? So let's just count. 1, 2, 3, 4. It is 4 units from 0. So we represent that by saying the absolute value of -4 is 4. When I'm asking the absolute value, I'm saying how far is it from 0? Well, it's 4 units from 0. So how far is 3 from 0? 1, 2, 3. 3 units. We represent that by saying the absolute value of 3 is 3. Notice it's not the opposite sign. A lot of people think, oh, if it's absolute value of negative, it's positive. Then if it's absolute value of positive, it's negative. That's not true. The absolute value of 3 is still 3. It's just asking how far is it from 0. And that is the end of the first lesson.